Let's find the time complexity of the following nested loops. So here we have two loops. The outer loop starts with index I is equal to 0 and runs till I is less than n. The inner loop starts with index 0 and runs till j is less than I. In order to find the time complexity of these nested loops, we'll have to find the number of times the inner loop would run. That is, let's go through few of the iterations. So for iteration 1, the outer loop index would be 0. The inner loop index would be 0. However, the inner loop condition is not satisfied, and therefore for iteration 1, the number of times the inner loop executes would be 0. For iteration 2, the outer loop index is 1. The inner loop's index starts with 0. And the number of times the inner loop executes would be 1. That is 0 to 1. Similarly, for the nth iteration, the outer loop index I would be n minus 1. The inner loop index will start from 0. The inner loop would run from 0 till n minus 1. And therefore, the number of times the inner loop would execute would be n minus 1. For the n plus 1 iteration, the condition is not met, so the inner loop is not executed. In order to find the total time complexity, we'll need to sum up the last column. So that would be 0 plus 1 plus 2 up to n minus 1. We also know that the sum of first n natural numbers is n multiplied by n plus 1 divided by 2. Here we have n minus 1 natural numbers. So in sum of first n natural numbers formula, n can be replaced by n minus 1. And that would give us the total time complexity of n squared minus n divided by 2. And therefore, the bigger time complexity of these two for loops with these given condition would be big O of n squared. Now the next step in the video is to see how the total time complexity of these nested loop changes when we modify the loop condition. That is, earlier in the inner loop we had j is less than I, but in this example j is less than equal to I. So again, in order to find the time complexity of this new situation, we'll have to count the number of times the inner loop will be executed. In order to do that, let's go through few of the iterations. So for iteration 1, outer loop index is 0 and the inner loop index is 0. Here, since j is less than I, therefore, even for iteration 1, the number of times the inner loop will be executed would be 1. For iteration 2, the outer loop index is 1. The inner loop index starts from 0. And therefore, the number of times the inner loop would execute would be 2. And we can see few more examples here. So in order to find the total time complexity, we are again going to sum up the last column. So it would be 1 plus 2 up to n. We are again using the sum of first n natural numbers. That is n into n plus 1 divided by 2. Here we have total n natural numbers, and therefore the total time complexity of these new nested loops would be n squared plus n divided by 2. The big O time complexity would be big O of n squared. Here I purposefully showed you two examples and how the total time complexity changes when the loop condition is either j is less than I or the loop condition is j is less than equal to I. You can also try out similar examples by changing the start index of j to 1, or maybe the start index of the outer variable I to 1 and see how the total time complexity changes. However, the big O time complexity would remain the same.